And now, because we have studied relation, finally we enter what is a function. This, what kind of x can you put in? Anything. So domain is all real number. What about the range? That means what kind of y can you get? Can you get negative? No. So it's r plus. R plus means all the positive number or zero. What is this function? This function is saying that I have a number mapped by the f, give me a number. So I have f, I have something, go inside f, give me something. This is real number. This is also real number. I can take any number here, the full real number, go inside this f, but for output, I only get the positive part. So this part I will never touch. Okay, this is domain, this is codomain, this is range. This guy linking these two is a relation. So this is the function. That means we are going to talk about function as a set, which is why we talk about relation. Why we need to talk about this? I talk about the transitivity, right? Function is also a relation. That means now I can do this. What is this? This means I have a set, real number, mapped to a function f, give me the output of f. Let me write it out f. Who said I cannot use this again to map into another function g and then give me another output? Then I can view this as what? A transitive property from here. So that means I have a function h that represents this f, g acted together. Then I can just write this whole thing as h, right? And let me tell you, don't underestimate this. This is exactly deep learning. What's deep learning? Deep learning, you draw a lot of dots. This is an input, and then you have those crazy number of lines. Okay, and then you have also those crazy number of lines. What exactly are these lines? F. What is this line? G. So in the end, people are just lazy. They just draw a bunch of dots and then just draw boxes and then draw an output. This is what? Composition between function. That means what? Transitivity in action. So this is why you need to know this. This means I can always replace two functions by another function. And as I told you, equivalent class, you may think that what the heck is going on? Why I'm talking about this? Here's another reason why this is important. This means what? One number have more than one way to represent, right? Same as function. These are all signs. You may learn the first one, but let me tell you, all that these are signs. That means what? Who said that a function have only one name? They are all signs. You will learn the second one later. Okay? So these are all the same thing. So that means for function, I also have equivalent class. That means I will now have a set. Inside this set is a bunch of functions, possibly infinite number of functions. All these functions are the same thing. And then I divide the whole world by all the equivalent class of functions. For example, these two functions are the same thing. And then here's another example, important. Don't tell me these two are the same function. This is the same thing I just told you about. They are not the same thing. They are the same thing after you cancel out the two. If after you do this, they are the same. But before you do it, they are not the same, right? And also, if I do not cancel them, can I put 2 inside? I cannot. If I put 2 inside, this is 0. Division by 0 is not allowed. So the domain of this function is real number, but not allowing 2 and 4. So all the number, but except this set. For this guy, what are the domain? Any r, but not 4. How do I show these two functions are the same? Same domain mapped to same codomain. But their domain is already not the same. I can say they are not the same function. Okay? If you think they are the same function, it's not wrong. I would say you make careless mistake because you think that this thing have no big deal. Now I'm telling you, these two lines have very big deal. You cannot just simply say, oh, I learned this in primary school or high school. No, this is big deal, okay? And again, this is the same thing. Nobody said one function only have one form, right? For example, they can even write out like this ugly function or even this, okay? Today, I just shock you. When you will see something, do not have a predefined thinking, oh, this is the only way you can write it down. You need to prove it. This is called uniqueness. If you didn't prove it, please think in this way. Whenever you see something, think of it as a set. And you just see this guy. You don't know what is inside here. You don't know. Maybe this guy exists. Maybe this guy doesn't exist. You don't know. This is the way you should view about mathematics. This is set, this is set, this is set. Nothing else. Okay, that's all for today.